So it's a much simpler way of doing things. Plus the two caps now are completely independent of each other. There's no connection. Okay, let's go through the wiring here. I'll just do this half of the bank. So the red wire shares this, so the red wire goes directly to the capacitor over here. Red wire from the coils goes directly to the capacitor. The capacitor, black negative from the capacitor, goes to this terminal over here, which is the positive of the relay. It's labeled the positive. And then when this turns on, it completes the circuit and completes the power going back to the coils through the diodes. Okay, that's the negative out, so that completes the circuit. Now the positive, now here's the discharge relay. So I have that red wire from the coils hooked right to it, the positive side of that. And then when this switches on, bang, it sends the power out to the one side of the two AC wire outputs. This happens to be the one with silver ink. Now to complete the circuit so it becomes a cap discharge, the ground of the cap over here, the ground of the cap goes over and connects to the other side over here to the other AC wire. Okay, and because the caps are independent, the coils are independent, I don't need any diodes or clipping circuits or anything there. I just run it straight over. So now when this relay discharges, it'll short this capacitor, you could call it, into the load going one way, and the same thing happens on the next power stroke coming with this other capacitor bank going the other way. So it's just like the other circuit, really, except I don't have so many relays. And now, like I was saying, it's independent with two separate generator. Here's the run cap for the rotovertor motor down here. It's 8 UF, happens to be for this motor. And here's the start cap, just to get it started, then you disconnect it. And here's another 9-volt battery, and as soon as I plug this battery in, it turns on the relays. So it supplies the power for the trigger side of the batteries. Here's the green wire, the white wire coming from the Hall effects. The two Hall effects are butted end to end. One creates a normally on, switches off relay. The other creates a normally off, switches on relay. And they both switch on and off simultaneously. So that's how I do the disconnect of the capacitor bank from the coils whenever they discharge. Through this trick of the two Hall effects, the two different types of Hall effects that create a different type of relay, either normally on or normally off. Use this kind of as a load also to drain the capacitor banks. Here's the second motor over here. So what I want to film today is get this thing running, take the output of this generator, pump it into this second motor over here and make it run. And here's the run cap for this. This is the same motor, but this one needs a 18 UF run cap. Well, this one needs an 8 UF run cap, so it's just how it happens to be. And all I'm going to do is plug the plug the power from this right into here once I get this one up to speed. Okay, I'm going to plug the rotovertor in. They're simple to work with. You just plug them in the grid or the inverter output, and then here's a start cap. You need this to get it going, and then you just disconnect it once it's going. So, I'm going to plug it in. There it goes. It's going 1800 RPM now. Yeah, it has an isotone. It's on about 300 milliamps now. I really don't feel like looking at that. Let's just get the other one going. 20.6 volts DC in that cap right now. It's going to be the same in the other cap. So don't touch it. Okay, I just hooked up the meter that's now in AC, and I have it to the output of the inverter, and it says 128 or so volts AC. So this is what's going to power the other motor. Okay, now we're over here at the second motor, and it's the same thing. I have a start cap hooked up, and I need to plug this into the grid and start right up.